Okay, so I'm going to run through this, and then if you have questions about the process, you can come and see me lunch and learn, and I'll review it with you again. So the goal here is we're trying to find the value of x, y, and z that satisfy all three of these equations simultaneously. And what we're going to do is we're going to use the elimination method to do so, but we have to do it in parts. So what we have to do is we have to choose a variable to eliminate, either the x, the y, or the z. And what we're going to do is we're going to eliminate that variable from two of the given equations, and then we're going to eliminate that same variable from another pair of equations from the original. So for organization, I call the top equation row 1, row 2, row 3, and you need to analyze it and figure out, okay, what's the easiest variable to eliminate from two of the equations? So I'm looking at it, and there doesn't seem to be a nice, easy one. So I'm going to work with x at the moment. But you want to think about it. And once you identify an easy one, remember you have to eliminate that same variable one more time from a different pair. And you always think to yourself, well, is that going to be just as easy, that same variable, right? Sometimes the easiest one right away leads to difficulty when you need to eliminate again. But I'm going to look at this and I'm seeing, well, if I multiply the second row by a -3 and add it to the top equation, I'll have opposite coefficients for my x variables in row 1 and row 2. So here's how I'm going to note that, right? I'm going to take -3 and multiply it to row 2. And then I'm going to add it to row 1. This is telling me what you're attempting to do, because I'm choosing to eliminate x from row 1 and row 2, but you could eliminate z from row 1 and 3 or 2 and 3. And if you don't tell me what you're doing, it's really hard for me to figure it out. So I'm going to distribute the number -3 to every term in row 3. Be careful. Do this slowly at first until you're really comfortable. That's going to give me -3x minus 9y plus 15z equals positive 21. And then I'm going to add that to row 1. So I'm just going to stack row 1 underneath it. Again, it pays to double check your work. There's lots of basic calculations here. We're multiplying and adding, and you're going to do it fast, and you will make a mistake if you move too fast. So just be careful. All right, so I'm going to add these two together, and right there, my variables for x disappear. They're eliminated. So now I have a -5y plus 17z equals, that's 21 and 27 here, okay? It's not a nice equation, but we're gonna have a deal. So notice this equation here has the variables y and z. So we're gonna repeat this process that we just did, right? And in doing so, we're gonna have to eliminate the x variable now, but we're gonna have to do it from a different pair of equations, right? So I chose row 2 and 1, or 1 and 2, right? So now I need to eliminate x, but from row 1 and 3 or 2 and 3. So I'm looking at it and I see a 3 here and a 5 here. I don't really want to work with row 1 and 3. I'd have to multiply both equations, so I'm going to get rid of that. But I do see a 1x and a 3x, so I could easily make row 2, sorry, where am I going here? Row 2 and row 3, that's where I wanted to focus, right? So I have a 1x and a 5x. I could easily make row 2 -5x by multiplying by 5. I'm going to do that. So what I'm going to do is I'm going to say -5 times row 2 plus row 3, and then I'll get started here, right? So that's going to leave me with -5x minus, and then take your time here, 15y plus 25z equals positive 35. Again, I always try to double check to make sure I didn't forget to distribute that -5 to all 4 terms, made sure I do it correctly. It's real easy to drop the ball there. And then I'm going to add it to row 3, which is 5x plus 7y minus 3z here equals x's are gone. So I'm left with negative 8y plus 22z equals 38. That's my second resultant equation, right? So now, this is where it kind of gets a little bit easier, right? I have the two equations in red. Make sure they're both in the same variable. I have a y and a z and a y and a z, right? So these are just turning out to be equations that aren't the nicest, so we just have to deal with them. So I'm going to rewrite them nicely. Negative 5y plus 17z equals 27 here, and then negative 8y plus 22z equals 38. So my choices are pretty limited, to be honest. There's a few things you could do to kind of simplify the first equation. You could divide it, but most of you are probably not going to do that right off the bat. So choose your variable to eliminate. You do not need to tell me what variable you're eliminating at this point, because it's pretty clear you only have two choices, y or z. So I'm going to multiply the top equation here by an 8, multiply the bottom equation here by a negative 5, and that'll allow me to eliminate the y's, right? So again, go through this process carefully because it's easy to make mistakes. So that's going to leave me with a negative 40y, and then 8 times 17 is going to leave me with a positive 136z equals, and then 27 times 8 is 216. Okay? And then for your second equation here, we got negative 5 times 8y. That's going to give me my positive 40y. And then negative 5 times 22 is going to leave me with a negative 110z. And then negative 5 times 38 is going to leave me with a negative 190. And now your y variables are set up to eliminate. When I add them up, they're gone. And then we're going to continue to add the other terms. So 136, and we have 110, right? So what is that? That's 26, positive 26z equals, and then we have 216, and we're adding a negative 190 here, and that's going to be a positive 26, right? Solve, z equals 1. Be nice if we're done, but now we have to finish solving the system up here. You can choose. You can plug z equals 1 into the top or the bottom equation. I'm going to choose the top. Negative 5y plus 17z equals 27. So negative 5y, I already forget the equation. Negative 5y plus 17z equals 17z equals 27. Just double check that I wrote that correctly. These are some of the mistakes that happen. You're just not writing the equation down correctly. And we're going to drop z equals 1 into here, right? So that's going to leave me with negative 5y plus 17 times 1 is 17 equals 27, right? Keep solving, subtract your 17. That's going to leave me with negative 5y equals 10, so y is equal to negative 2. Again, it'd be nice if we're done, but we have one more step, right? So that's two values. We have a y and a z. Now you have to go back up to the original, and we're going to substitute these two values into the original. So I'm just going to work off the top one, but you can choose whichever one of those equations you want. So 3x plus 4y plus 2z, 3x plus 4y plus 2z equals 6. 3x plus 4y plus 2z equals 6. And again, before I do my substitutions, I'm just double checking I wrote it down correctly. 3x plus 4y plus 2z equals 6, and I'm substituting z equals 1 and y equals negative 2, right? So 3x plus 4 times negative 2 plus 2 times, I think it was 1 again, double check. So So my y is negative 2, and I believe my z is 1. Yeah, z is 1. So it's 3x minus 8 plus 2 equals 6. 3x minus 6 equals 6. Add your 6, and you get 12. Divide by 3, and you get 4. Now, this is the solution to this system of 3 equations and 3 variables. Always must go in an ordered triple when we're dealing with these 3 variables. So it's 4, comma, go back up, y is negative 2, z is 1. Negative 2, comma 1. This is the point of intersection of those 3 planes, and it's an ordered triple and satisfies all 3. And you can check, you can substitute all 3 of these values into the equation, each equation, and it should test out cleanly for you.